All right, so everybody has opened this page. Let's run it, right? And we get this welcome here. Now, if you do what I did and search for Python asteroids, you're going to find this link, right, on Code Sculptor, which is based on this website. There's a Coursera course, and in that Coursera course, students are asked to write this game. All right, we're simply going to we're going to start slow, not do such advanced stuff from the very beginning, but I would like you to experience the game, right? So if you start running, which is you press this button here, right? A separate window opens, all right, and you get this screen. We click to start, and you have this little ship here, left and right. Left and right moves the asteroid around, and I think up and down will move it forward and backward, right? But there's friction, so there's inertia and there's friction, right? And eventually the ship gets destroyed, and you have a certain score and lose all your lives, right? So the very nice thing about this package or this environment is that I don't have to teach you how to download packages in Python, which for Windows turns out to be a nightmare based on last year's experience. So literally, again, I had to go to everybody's machine and type the stuff myself so that the packages could be downloaded. All right, so somewhere there's documentation, and we're going to use the documentation to write a little graphics application, right? And we're going to start simple. We're going to try to have a ball bounce off the walls, all right? So that's about the simplest thing we can do, right? In the process, we're going to learn how animation is done, not just in Python, but in any programming language. So let's go through the sample application that we have here. You see that this environment has opened with a sample app, and when we run it, right, we just get this message, welcome. So first of all, let's try to make this welcome move somehow and see how we might be able to do that. Oh, so we can click. Oh, click me here, and we get good job. Why is this now? Oh, there's a mouse here. So is it trying to? It was accidental, right? So so we can learn very quickly how to draw something, and how to click something, all right? And one thing we could do is make this text. So instead of clicking, when we click, we could have the drawing go to a different place on the screen. Now you might guess as you look at this that these are coordinates, right? So obviously, if I'm going to move them, for instance, to 0 and 0, we're going to discover where the system of coordinates is. And we see it disappeared from the screen. So my guess is actually that 0 and 0 is here, and 0 and 0 corresponds to the lower left side of the text. So all the text is above, right? So I will say that y is 100, and we're going to probably see the text all to the left. Okay. All right. So every time we click, we would like to change these coordinates. All right. So I am going to add initial coordinates and let's pick something that would make sure that the text is on the screen. Okay. And we're going to say here initial coordinates. And it's clear now that this hasn't done anything, right? It's the same program. Okay. Now every time we click, instead of changing the message, all right, instead of changing the message, we're going to change the coordinates. So we're going to say global initial coordinates. And actually, let's not call them initial. Let's call them coordinates. Because once we change them, they're not initial anymore. Global coordinates. And then we're going to say x equals coordinates 0, y is coordinates 1. All right, coordinates equals x plus 1, y plus 1. All right, so this draw will continue to draw constantly. I have no idea what this 48 means. We're going to find out. For the time being, let's check that this works, right? So displayed at 100, 100, and as I press click me, you can see it moving slowly on the diagonal towards the right and down, right? So x plus 1, y plus 1. Now, how does this happen? Well, that window that you see on the screen, right, is refreshed with a certain frequency, typically 30 frames per second. That's a very typical frequency, right? Because TVs have 30 frames per second, and then you want to play games on the TV, right? So computers are capable of much higher frequency. So very frequently you would have 60 hertz or 60 times per second, or even 100 hertz or 120, right? So extremely high resolution monitors, when you're very up close, you're going to see a little bit of flickering, which is very annoying unless the frequency is very high. But 30 times a second is a very typical value, right? So in the background, right, because we are saying frame set draw handler, we have this draw. This draw function is called automatically 30 times a second without us doing anything. So this is a very basic mechanism for animation. So what we do is, as we execute this function, we change data that affects the way the drawing is done. And that will, next time the draw is called, and it's called like very, very frequently, right? So 30 times a second is something you can't distinguish between this frame and the next frame, right? You will have the feeling of animation. All right, instead of using click, we could have this happen automatically. All right? So every time we do draw, because it's called 30 times a second, right, we can also increase a tick. Let's put everything at the top. Is this clear? Is everybody following how this works? Before going forward, I want to find out what this 48 is. Again? Oh, it's the font size. Okay, good call. Excellent. So if we make it higher, the font will be bigger. Actually, it's probably good if we make it smaller, and then the animation would look somewhat nicer because the whole thing fits, right? And another thing that we might want to do is to increase the size of the frame. So a much nicer size is 800 by 600, right? So then we have a big frame and the animation is happening. Now, let's try to make it happen automatically without us having to click, right? So let's say I would have a tick here, right, which is initially initialized with 0, right? And every time I call draw, right, I would say global tick. And by the way, why do I say global tick? Why do you think? Because I'm referring to symbols that are outside of the function, right? And that's the way we do it in Python. In most other languages, it's automatic. So when you use a symbol, the compiler first looks inside the function. If it's not there, it enlarges the scope. It looks in the larger scope. If it's not there, it enlarges the scope even further until it gets to the global scope. Here, if we want a variable that is defined in the global scope, that is not inside any function, then we have to say inside the function that that's what we want, the global tick, and not a local tick. All right, so what do we do? Every time draw is invoked, we can do tick plus equals 1. We increase the tick by 1, right? And then what else do we do? So we want the animation to happen automatically. Louder. We have to get into this frame of mind. We have a loop already, right? This guy, when it starts, it calls draw 30 times a second forever. The loop is given for us, yes? An upper bound. We don't necessarily want the computation to terminate because we can always close the window, right? We pretty much want to go until we close the window. But how can we make the animation happen automatically? What makes the animation happen? Again? But we don't want it to happen on click. So what inside click makes the animation happen? This one, right? If I remove this one, there's no more animation. I can click forever and nothing will happen, right? Clear? So if I want it to happen forever, right, I should put it, automatically, I should put it inside draw, right? Because that's the thing that happens automatically without my own intervention, right? So I can go here, and actually I don't want to remove it. Let's just copy it. Okay, so I can do it here. But if I leave it like this, what's going to happen? Let's try. I'm not sure if you noticed what I did before we go there. I pressed accidentally on Command S. And on Windows, it's going to work on Control S. And automatically you see that this thing has been added to the URL, right? And for each of you, when you do that, it's going to be different. So now you can take this and use it as a reference to this version of the file. So you can give it to somebody else, or you can move to a different computer. And if you have this link, you can open this version of the file. You save again, you're going to get another link, right? And you're going to get multiple versions of this file. And that's the way you save. Every time it's going to give you another link. And actually, it also opened a different, no, it didn't. It's the same window. Okay, so let's see what happens. So we copied this here. We didn't protect it in any way, right? Let's see what happens. You have to be to pay attention very carefully. What happened? It's not an error. It's, oh, there is. Oh, coordinates is not, okay, so global coordinates. Okay, let's see. Oh, okay. Oh, it's actually not that fast. I thought it would be so fast as to be out of the screen. Okay, we have to be able to make it faster, actually. So let's check the documentation. How do we make it faster? Timers. Create timer start. Oh, no, this is not. Screensaver, blinking test, reaction time. So I have to be able to set how many times a second I want to call it. I'm going to peek into this one, because this one for sure Okay, let's just look for 30. Where is it? Oh, not where I thought it would be. Angle, velocity, friction, frames. No. It's very strange. Okay, we'll notice, we'll figure it out at some point. Timer at start, frame at start a timer. I should be able to say because if that's what happens, that speed is pretty lame.
You can make it more
That's true, but I don't want to. I should experience the fact that it's 30 times a second. So markers, lines, simple plot. All right, I'll figure it out and does this help in any way? Frame dot. No, doesn't. Frame object. Frame. What do we have? Frame. Create frame. Okay, I'll try to figure it out. All right, but normally what would we do is, assuming that it's called too fast, is, for instance, we want it to be called every second tick, right? We want it to be called every 10th tick, right? We can say if tick equals 10, right? And then we perform these operations. We don't even have to do the draw text, right? We only call the draw text. No, we have to do the draw text every time, sorry. And then also inside here, we have to say, we have to reset tick to 0, right? So we say tick is assigned 0, right? So that next time, right, it gets to be incremented from 0 to 10. So if we run this, now you can see that it goes a lot slower. But we still have interactivity here. If I click on Click Me, you can see that it sort of accelerates. Right? The interactivity is still available. All right. We could make the interactivity, for instance, we can bring it back, right? -10. And if we do that, right, it starts sliding down, and every time we click, we just bring it back, right? We can play in a variety of ways. Let's try to change the text into a disk. Okay, so everybody understands this? Yeah? All right, so the canvas object should be able to draw a circle. Right, we have a, and the circle is in fact an ellipse. All right, so these would be the center. These would be the two radii, right? If we have an ellipse, there's a horizontal radius and there's a vertical radius. Let's, just for fun, let's not make them equal from the very beginning. And then we have a color for the edge, and we have another color for the middle, right? And I'm just gonna copy this because it's as good as anything else. And instead of drawing a message, I'm going to draw a circle, but I want to draw it at coordinates. All right, so now the message is no longer needed, and if we run, we have a circle. Oh, I see. It's not actually, it's not an ellipse. It's the thickness. It's the thickness of the edge. So if I make this just 2, it's going to be something that looks a bit more pleasing. Right? And it's the same thing. Instead of having the text, right, we draw the circle, but we have the same behavior. Okay? Now, instead of clicking and bringing it back, let's add 2 buttons. One that is faster, that makes it go faster, and another one that makes it go slower. All right? So we want to add a button which we call faster. We're going to call it faster click. And this is going to be slower click. Now, how do we make them faster and slower? Well, we're going to have another global variable, which we call gradient, speed gradient, right? So let's have another variable called speed gradient, which we set to 1 initially. And as one of you suggested, instead of having 1 here, right, we can make it move instead of 1 pixel at a time, we can move it several pixels at a time. That will make it move faster. If we do that, we actually don't need really the tick anymore, right? So we could get rid of the tick. All right, so let's just forget about the tick. And we're going to increase this x plus gradient and speed gradient, sorry, and y plus speed gradient, right? Now, speed gradient has to be global, right? And we need to write 2 functions, a faster click and a slower click. All right, so faster click, what do we do?
We set speed gradient to a high number.
Mm-hmm. Very good. So plus equals 1. Slower click. Okay. Now, because we're subtracting 1, the number can become negative, and at which point it will start going in the opposite direction. So let's see how that works. So you see it moves a lot. Oops. Speed gradient is not defined. And of course, we need to say global speed gradient. And if I say slower, right, and So now it's 0, now it's 1, now it's 2, now it's 3, now it's 4, and it's out. But guess what? It's still going. I hope. Yeah, you see? So it doesn't quite, the fact that it goes out of the screen, it means that we can't see it, right? You can think of the screen as being extended infinitely, right? And any object you put, if you put it at 2 kilometers away, it's there, it's just that you can't see it. The screen is, the viewport of the window is not large enough. Okay? Now, another thing we would like is to sense that we have reached the edge and to make it bounce, right? So before doing that, it's not good practice to have these numbers hardwired, right? Because if we want to make any changes later, we don't know what they mean, and if they appear in many places, then even we want to change them. If I want to change the window size and I use 800 and 600 everywhere, then I have to go all over the program to change them, right? So instead of that, we prefer to have them named, right? We prefer to give them names. So I'm going to say window size equals 800 and 600, okay? And then radius equals 30, right? And I'm going to go here and say radius, and I'm going to go here and say size 0 and window size 1. Okay? And essentially we haven't changed anything. Everything works as before. And I'm going to make the ball larger. Okay. Now, how do we know that the ball is expected to bounce?
Like it touches the boundaries.
Mm-hmm. Right, so we always want to perform this movement, right? But before performing the movement, we want to check whether it needs to bounce. And when it bounces, what does it mean to bounce? The direction changes, right? So essentially what changes? Because you've seen how we change direction. Right? So if I change the speed gradient to its opposite, right? Then I would make it change direction. Now, when it bounces on a horizontal edge, I only need the speed gradient on the vertical axis to change, right? And when it bounces on a vertical one, I need the horizontal gradient to change. So I can't have a single gradient anymore, right? I need to have two gradients, 1 and 1. I'm also going to change the coordinates to, and I'll tell you why. Because, and let me check that this, I should have checked if it works, right? So if I do that, I can say, I can say here, xy is coordinates. So Python is nice in that way, right? So it will make x equal to coordinates 0 and y coordinates 1. So I can get rid of this. And then I can say here x plus speed gradient, y plus speed gradient. All right, so this is nice. Then before doing this operation, right, I'm going to want, instead of having speed gradient here, I'm going to have Sx and Sy. All right, and I'm going to say Sx, Sy equals speed gradient. And before doing that, we're going to check for check if time to bounce. So what would make it bounce on the lower edge of the window? When do we know that it's time to bounce on the lower edge of the window?
When it goes beyond 600, when it's 600, the y coordinate is 600.
Yes. So it's window size 1, right? So if the coordinate is window, so is it window size 1? Is it 600 or is it less than that? These coordinates are attached to what? Louder. So this is the circle, right? The coordinates are attached to the center, right? So if I go and bounce, where's the center compared to the edge?
Radius plus
At a distance of radius, right? So so we're going to say xy equals coordinates first, right? Doesn't hurt to say it here. And actually Sx, Sy. We're gonna put it here, but we don't compute the next coordinates yet. Okay. So if x plus radius, all right, and we want to be on the safe side, is greater or equal than window size 1, right? And what else needs to happen? The y gradient has to go down, right? So we're gonna make the convention that positive gradient goes down, negative gradient goes up for the vertical direction, right? And positive gradient on horizontal, positive gradient goes to the left, negative gradient goes to the right. So if x plus radius is greater than window size 1, then the height, right? And Sy, sorry, why are letting me say rubbish? Y plus radius is greater than window size, and Sy is greater than 0. Okay? Then, right, and we want to change the y direction, right? So what do? Sy is assigned minus sy. That's all we need to do, right? And it's going to bounce.
But it will bounce back.
Yes, right? You haven't seen the game? Like the bouncing ball inside a square?
But will it bounce back this way? Or?
Well, if it touches the bottom, right, it should bounce like a billiard ball, right? So I only change the y gradient, the x gradient stays the same. So that's the natural, right? Now I might hit exactly the corner, in which case, so let's see whether it's time to bounce horizontally. Right? So this is bottom and right. Okay, how about on top and left? So if y minus radius, right, is less than or equal to 0 and sy is less than 0. Sy equals minus sy. If x minus radius less than equal to 0 and sx less than 0, x equals minus sx. Okay, now we changed x and sx and sy, right? So we're going to say back that speed gradient equals sx sy. I want to put back the gradient. Okay, so now this should work. Notice that we still have the faster click and slower click, right? So now that's the interesting thing, right? If we want to make it faster, what do we do? Well, if it's negative, we should make it even more negative, right? If it's positive, we should make it even more positive, right? So that's a good idea. We should multiply it by something, right? But then we're going to go exponentially, right? That's going to be an interesting, but that's a very simple solution here. The other would be to check, is it negative? Then make it more negative, subtract one. Is it positive? Then make it more positive, add one. But let's try the multiplication. So let's say speed gradient star equals 2. And we're working with integers here, so it doesn't make sense to say 1.25, right? It would be nice if we would we'd be able to have more control about how we increase the gradient. But so let's see what happens now. I'm just gonna make sure that we see it bounce a few times before playing with the buttons. Okay. And now you have your own screensaver, right? So after a while, it will take a while until it bounces straight on the corner and you'll see it bouncing correctly. So generally, the bigger the ball, the less you have to wait until it bounces. That's why. And yeah, let's try that. So let's go faster. I know what is happening. I'm pressing too hard. So somehow this doesn't work. Oh, we didn't, in both cases we increased it, so here it should be divided by 2. But, oh, I can't do the speed gradient star equal 2 because now speed gradient is a tuple. So what do? We say equals 2, so we'll say tuple. 2 times t for t in speed gradient. Right? We learned this. And here we say t divided by 2. Okay, and this should make it work. Ah, so if we make it 0, so there's still design flaws in the program, right? Because if we keep dividing by 2, it will get to 0, and then 0 multiplied by anything will stay at 0, and we can't make it work anymore. Clear? Okay, more effects. So, for instance, you might want to change the color of the circle when it bounces. How do we do that? Well, instead of using yellow and orange here, right, we change the color, right? So let's just work with one. Color equals yellow. And then we want a list of colors to change from, right? And actually, let's not call it yellow. Let's say that the color has the value 0. Color index, let's call it this, equals 0. And then we have colors, and we're going to create a list of some colors. So yellow is 1, red. I'm not very good with colors. Blue, I think, is also there. Magenta. I like magenta because for a long time I couldn't tell the difference between magenta and purple. Enough, you can add more. All right, so colors has a length, right? And every time we bounce in either direction, right, we can say color index equals +1 modulo len of colors, right? So we don't want to, we always want to be inside the range of this array. And so by the way, let's simplify the code a little bit, because you see this instruction here, this thing, is the same as this thing, right? Because I want to type less. So so I would like to get rid of this if. How do I do that? Take this condition, and I'm going to add it here. So very good. I'm going to put this one in a bracket and this one in another bracket. And in between, I'm going to put an OR. Very good. Not doing it shows that you're beginners. So that would be a not spotting this right up front will make an experienced coder know that you're not experienced. All right, so now it's easier, and then because of that, I only have to copy this only once. Oops. All right, so we change colors on every bounce. And then when I go here, instead of saying yellow, I'm going to say colors, color index, right? Yep. Okay, so global coordinates, colors, color index, and they need to be global. And let's see how. Okay, I would have liked the other one to change the inside because it's more spectacular. So let's keep the yellow here. Or what's a good color here? White. Okay, white because it's black. The background. That's a good color. Let's delete the orange. Okay. And we let's say we don't want to, or actually let's still obey the laws of physics, but let's make it not go at angles that are always horizontal or vertical, or always 45 degrees, right? So it's always a 45 degrees, some sort of a diagonal trajectory, right, or parallel to the diagonal. So let's try to change that. So instead of having faster and slower coordinate on the both x and y axis, let's make it work only for the x gradient, the horizontal gradient, right? So then you're going to, I'm going to speed it up only on one direction. So that can be interesting. So faster click. I'm going to have now speed 0. So we're going to pick x times 2 and one, and same here. But division. Okay, so and you can see it working fine in spite the fact that it's not going on the same angles anymore. Obviously, it would be interesting to add now separate controls on each direction. Right? Now we can also make it disobey the laws of physics. That every time when we bounce, instead of bouncing exactly to the minus, we can make it bounce to the opposite value, plus minus something. We don't want the laws disobeyed very much, right? Just a little bit. So let's try that, right? So we want plus or minus 1, but randomly, sort of. All right, so one thing I'm going to do is I'm going to start from a higher speed gradient here because it's just not fun to wait. Okay, and then when I say sy equals minus sy, let's do here plus, and we should have math.random available. Standard modules, math module, math dot do you see it? Random module, okay. Random choice. All right, so let's pick a random choice between -1, 0, and 1. This is the easiest thing to do. So I have to import random. So here we're going to say import random. And then here we're going to say choice. And we're going to say -1, 0, 1, right? So one of these three values was going to be picked randomly and alter sy, right? And similarly, we're going to do a similar thing here. And let's see what happens now. So you can see that it's not. I slowed it down to, and it keeps speeding up. Okay, interesting. And another thing that we may want to do is print the current sx and sy, right? To print the gradient to have some sort of control, right? So next to the the buttons, which we have here, we can say frame, and I'm hoping it's add label. The frame, and then I should be able to say add label, right? And add label text width. So text should be enough, and let's see how that works. We're going to say frame.add label. That's going to be interesting. So we're going to say label text. All right, and define the label text as a global variable. And we say sx equals plus speed gradient 0, sy equals plus speed 1. Okay, let's see how this one works. Cannot concatenate. Really? All right. So you can have the join and does this work? And then label text, does it need to be? All right, so label text, we need to change it every time. And we're going to take exactly the same assignment and put it here. Join takes exactly 2 arguments, 5 given. Take exactly 2 arguments. We can make this a list. Expected string object found. All right, I have to remember how join works. Yeah, so if I say I think this needs to be a string. But still, that's not the error message. All right, let's look at documentation. But that's standard Python. Types, strings. Again, please.
To keep it as a list, instead of using pluses, use commas. And the top.
Oh, the bottom one is different than the top, and I get the error for the bottom. Good point. Thank you. All right, so you see the label here, right? The label is a way to put up a piece of text. All these controls that we're adding, they will go into these control area. right? Then we can add buttons and labels, and so as I go faster, unfortunately, this thing doesn't change. And the problem is that if I would say add label, then we're going to add many labels. So how do I get something updatable? Graphics modules, frame. Oh, control set text. Okay, that's good. So so another thing we're going to do is label control equals none initially. When we reach this point, we're going to say label control dot equals frame dot add label, right? So this is what happens when we reach this point. It's not only that we add the label, but the result of this is put inside this variable, and this is a control. It's sort of a handler on the object that we have created, so that when we reach this point, we can say label control dot set text, and we set the text. So I am going to break this line in two, right? So this statement places the label on, and label is just a piece of text. It's nothing. It's like draw text, but the draw text work on the canvas, work on the left hand side of the window, and then on the right hand side of the window, and on the left hand side of the window we add these controls, and label is just a way of putting text there. So this instruction will put the text with its initial value, right, and then creates this label control, and then on this label control we can change the text. This is a handler, so to speak, right? A way to referring to that thing that has been placed there, and we can do stuff to it, right? And one thing that we can do is set the text, and this should work now. So as I change, right, so you can see that as they bounce, we can see the values, and we can make them faster. Slower. Even slower. So now we can play in a variety of ways with it. So next time we're going to learn everything. We're going to use everything we learned today to actually try to create the asteroids game, or some version of it. We'll see how far we can go. But definitely we'll be able to put the spaceship and make it move, and very likely we'll be able to have the asteroids going at us, and we'll see whether we can make it to the point where we actually can shoot asteroids and compute the collision between the bullet and the asteroid and make it explode. Cool? Questions? So you see, we're out of luck with this guy. We keep picking. Oh, it never bounces, right? So because of that, once it's 0, it stays at 0. It's still like, reasonably continuous. It's a bit flickery, but so you can probably do about, it definitely doesn't do 30 frames per second, but cool. This is it for today. No questions? Thanks for coming. See you next time.